Good morning. Today we are going to start 8-1 angle and angle measures. So let's review what an angle is. An angle is simply a rotation of a ray about a fixed point. So as a reminder, our quadrants are named counterclockwise. So here's 1, 2, 3, and 4. Our angles will always start on the positive x-axis. This is our starting point for any angle. And then we draw the angle. You will always draw an arrow showing which way your angle is going, and then you will label it with the degree or radian. So our positive angles are always rotated counterclockwise. And the arrow for our angle will always be on top. So if we think of our angles, if you take an angle and you continue to drag it around the whole circle, that point on the end or the tip of the angle would make a circle. So if we remember, our degrees, total degrees for our circle is 360 degrees. If I break that up into 4 parts, because there are 4 quadrants, this is going to be 0 degrees, 1/4 of it is 90, half of it is 180, and 3/4 of it is 270. And then back to the beginning again is 360 degrees. So if I want to make an angle of 120 degrees, I will start on the positive x-axis. I will go past the 90, but yet not quite to the 180. And we are not going to take our protractors out for this. We are just going to estimate where that would be. And we are going to draw our arrow showing which way I went. And then I will say this is a 120 degree line. Okay? It does not have to be exact. It just has to be in the right vicinity. Next, we have negative angles, and these are going to have a rotation of clockwise. And whenever I draw the arrow for this, it will be underneath. So this is still 0. It is always my starting point. Straight down is -90. Across is -180. And straight up is -270. So if I want a -150 degree angle, I will start, and this is back to -360 again. I will start on my 0 line. 150 is closer to 180 than it is to 90. So we'll draw the arrow underneath it because I'm drawing the direction I am going, so that is a -150 degrees. Quadrant angles are simply the angles that lie on a quadrant line. So we have 3 angles that lie on the x-axis. That is 0, positive or negative 180 degrees, and positive or negative 360 degrees. The y-axis are positive -90 degrees or 270. So if I want to draw a 180 degree line, I start on 0, 180 is straight across, and I draw my arrow showing which way my 180 degrees goes. Okay. If I want to draw a negative 90 degrees, I again start on the 0 line, negative 90 is straight down, draw an arrow showing which way I went, and label it. So next, let's look at how we convert from degrees to the other type of measure for angles, which are radians. So degrees are the unit of measure that we are most familiar with, but we can also measure in radians. Radians always involve a pi. So to convert from degrees to radians, we will take our degree and you will multiply by pi over 180. This will get me pi radians. So when we convert from degrees to radians, we are going to consider pi a variable. Okay, it will always be in your answer. You will never multiply it out by pi. So if I want to convert 45 degrees, it's 45 times pi over 180. So multiplying the tops, I get 45 pi over 180. So what I'm going to do in my calculator, I'm going to do 45 divided by 180, and then turn that decimal back into a fraction using math, enter. From here, you will get that it is 45 over 180 is 1/4, so it's 1 pi over 4. Just like normal, if we have a 1 in front of it, we don't necessarily need it there, so it's really just pi over 4 radians. Take a second, pause the video, try 300 on your own. Hopefully you paused the video and you've tried the 300 on your own, so let's take a look at it. 300 times pi over 180. So I get 300 pi over 180. And we need to reduce, so 300 divided by 180 ends up getting me 5/3, so it's 5 pi over 3. So now let's look at converting from radians back to degrees. We're going to just do the reciprocal of what we just did. So we want pi radians times, instead of multiplying by pi over 180, we're going to multiply by 180 over pi because I want the pi's to cancel out. And this will get me my degree. So let's try the first one. Pi over 3 times 180 over pi. So we reduce or cancel out my pi's. I end up with 180 over 3, which gets me 60 degrees. Again, take a second, pause the video, try 5 pi over 6 on your own. So hopefully you were able to pause the video and do 5 pi over 6. So let's write it out. So it's going to be 5 pi over 6 times 180 over pi. So my pi's cancel out. So I'm going to do 5 times 180, which gets me 900. On bottom, I have the 6. 900 divided by 6 is 150 degrees. So let's take a look at graphing some angles, both in degrees and in radians. So 48 degrees, first thing I always do is draw my quadrants on there, my quadrant angles, so I know where I'm going. So 48 degrees, I start at my 0 line. 48 is about a little over halfway between 0 and 90. So I draw my angle, draw my arrow, and I label it. That is all there is to it. Negative 212. So I draw my markers on there. So it's 0, negative 90, negative 180, negative 270. So I start at my 0 line. 212 is about halfway between 180 and 270. So I'll draw it, draw my directional arrow, and label it. Next, 270. So this is going counterclockwise. So I start at 0, I draw my line straight down at 270, draw my arrow going all the way around. And it's very important that you draw the arrow showing which way, because that could be a negative 90 degree angle or a positive 270. Without the arrow, I don't know which way you're going. Now, notice these last three have switched to pi. If you can do it in pi, I would prefer that. So my labels are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Because remember, a full circle is 2 pi radians. So 4/3 is 1 full pi plus 1/3 of the way more. So here's 1 pi plus 1/3 of the next distance. So this right here is 4 pi over 3. If you are not comfortable with that, convert. Use the conversions up top that we just did and figure out 4 pi over 3 is really 240 degrees. Draw your 240 degree arrow, but label it in radians. So I want you to keep the units that the problem is given in, but if you need to convert to get the right placement, do that. So the next one, I have negative radians. So this is 0, negative pi over 2, negative pi, and negative 3 pi over 2. So negative pi over 6, if I convert it, is a negative 30 degrees. So I draw it here. Here's the negative 30 degrees. Draw my arrow, but I'm going to label it in radians. And finally, negative pi. So 0, negative pi over 2, negative pi, and negative 3 pi over 2. Since it is a quadrant angle, I don't need to convert anything. So here's my 0, here's my negative pi. I put my directional arrows and my label. Let's talk about coterminal angles. Coterminal angles are angles that share a terminal side. Okay, that means they end in the same place. To find a positive coterminal angle, you are going to either add 360 degrees, because that's one full circle, or add 2 pi, because that is one full circle in radians. To find a negative, you're going to do the opposite. You're going to subtract 360 degrees or 2 pi. So coterminal angles are angles that contain multiple rotations. Okay, if I draw this out, they're going to go around more than once. And I will show that using a spiral. So if I want to find a positive coterminal angle for 60 degrees, I'm going to take 60 and I'm going to add 360 to it. I get 420. A negative coterminal angle, I'm going to subtract. So 60 minus 360 is a negative 300 degrees. For the radians, I'm going to do the same thing. So I'm going to do 7 pi over 6 plus 2 pi. In your calculator, you are going to just type 7 divided by 6 plus 2. Then turn it back into a fraction and put the pi with it. So when you do, you get 19/6, so it's 19 pi over 6. Okay, I'm going to do the same thing for the subtraction. So 7 pi over 6 minus 2 pi. Remember, we're treating pi like a variable right now, so it's 7/6 minus 2 is a negative 5 pi over 6. So now let's take a look at some angles that we're going to have to draw that have multiple rotations on them. So if I want to draw an angle of 1,116 degrees, I need to figure out how many 360 degrees are in there. So in my calculator, I'm just going to take 1,116, subtract 360, and I'm going to keep doing that until I get to a value that is between 0 and 360. So in this case, I would have to do it 3 times. So if I subtract 3 360s, I get 36 degrees. So here's my 0. Here's my 90, 180, and 270. So I'm going to go around, and this is where we draw our spirals. I'm going to go around 3 times. 1, 2, 3. And now I'm going to draw a 36-degree angle. So that is about right here. So I will continue my arrow or my spiral until I get to that line, and then I will say that is 1,116 degrees. Okay, same thing here for negative 585. I'm going to add 360 until I get to a negative number that is between 0 and 360. So this gets me, if I add 360 degrees, I get a negative 225. Well, I can graph that. So let's put that on there. 0, negative 90, negative 180, and negative 270. So we will go in a negative direction, 1 complete spiral, and then 225 degrees is right here. So I'll continue my spiral around till I get to there, put my directional arrow, and I will put a negative 585 degrees. So 10 pi over 3, we are going to add or subtract 2 pi until I get to a number that is between 0 and 2 pi. So if I take away 2 pi, so 10 over 3 minus 2, I get 4 pi over 3, and that's a number between 0 and 2, so that's okay. So I'm going to graph it, 0. Remember, this is pi over 2. Negative pi, positive pi, and 3 pi over 2. So 4/3 pi, if you need to, again, convert it to a degree. You can do that, but when we label it, we're going to label it in radians. So it was 1 complete time around, and then 1 pi more plus 1/3 more of a area. So that is 10 pi over 3. And finally, the last one in this section is negative 49 pi over 12. I need to add 2 of the 2 pi's to get it between 0 and 2 pi. So that gets me a negative pi over 12. So it's going to go around in the negative direction 1 spiral, 2 spirals, and then a negative 12th more. So that's a negative 49 pi over 12. Okay, so when we are given, so example 2C is taking it and doing the opposite of what we did. I'm giving you a picture, now you have to find the degree. Okay, and it says keep the units consistent. That means if I give you some information in pi, I expect my answer in pi. If I give it to you in degrees, I expect my answer in degrees. So looking at this first one, so I know it is a positive angle because it is going a positive degree. And I know from this line to this line, well, that's 180 degrees. So I have 180 there. And then it says from here to here is 120. So I'm going to add 120 degrees to that. So my total angle is 300 degrees. On the next one, we have a spiral forming. Again, it's going counterclockwise, so it's a positive direction. So if I look at this, I have 1 complete spiral. That is 360 degrees. And then I take the next biggest chunk I can. So from here to here, that's 180 degrees. And then next, I have this little piece, and that is 40 degrees. So we add them up, and we get 580 degrees. So this one is going in a negative direction. So first thing I look at is how many spirals do I have. So I have 1 complete spiral. So that is 360 degrees. I have another complete spiral. That is another 360 degrees. And now I'm looking at the biggest chunks I can. From here to here is a 180 degrees. So I just need to figure out, well, what is this little mark in here? Well, if all of this is 175, and I know it takes 180 to get to the other line, that means that little mark inside is just 5 degrees. So I add it all up, and we get 905, but I know I went in negative direction, so it's a negative 905 degrees. Okay, this one you'll notice we have something in radians, so we are going to do everything in radians. So I find out my complete circles. I have one complete circle, so that's 2 pi. I have a second complete circle, that is another 2 pi. I have from here to here is just half a circle, so that is just pi. So what is left? So if I look at this, what is left? All of this right here is another pi. But I don't have a third of it. So that mark is a third. So the distance from here to here will be 2/3 of the pi, because the whole distance would have been pi. I don't have a third of it, so that is 2 pi over 3. So we add our numbers and we keep our pi's. So it's 2 plus 2 plus 1 plus 2/3, and we turn it into a fraction, and you get 17 pi over 3. And it was in a positive direction, so it's a positive radian. This last one, it's in a negative direction, so we're going to keep in mind our answer is going to be a negative. So when I look here, there's one complete circle. So that was 2 full pi's. Here, on the next part, I can go all the way from here to here, because I know what the green mark is, and that is 3 pi over 2. And then the green part from here to here is just 2 pi over 9. So in my calculator, I'm going to do 2 plus 3 over 2 plus 2 over 9. Turn it all into a fraction, you get 67 pi over 18. But it went in negative direction, so it's negative 16 pi, or 67 pi over 18. Last thing we're going to do is a reference angle. So let's take a look at it. So a reference angle is an angle theta prime. That's what that little line means right here. This little line just means prime. Associated with an angle where theta prime is an acute angle. So remember, that is between 0 and 90 degrees. Formed by the terminal side of angle theta and the x-axis. But what I want you to ask yourself, as we do every single one of these questions, the only thing I want you to ask yourself when it comes to reference angles is, how far from the x-axis is it? So again, there's some formulas down below, and I'm going to give them to you, but when we do it, we're not going to look at necessarily the formulas. I don't want you to get bogged down by the formulas. So if it is in quadrant 1, so that would be some angle like this. So this is my angle. My reference angle is how far from the x-axis is it? It is this. It is the same thing in quadrant 1. So my reference angle is just the angle. In quadrant 2, so it's here to, let's say, here. So here's my angle theta. My reference angle is how far is it from the closest x-axis. My closest x-axis is this line right here. So here is my theta prime. This is 180 degrees. So to find theta prime, you are going to take 180 and subtract theta. If it lies in quadrant 3, so here's an angle. So that's my theta. My reference angle, again, here's my closest x-axis. So this is going to be my reference angle. So this again is the 180 line, but it went past that. So to find your theta prime, it is going to be your theta, because it went past it, minus the 180 degrees. And finally, if it lies in quadrant 4, here, so let's say here, so this is your theta. Your theta prime is just this line right here. So again, on the standard XY axis, this is 360 degrees. So your theta prime will be 360 degrees minus theta. But I don't want you to get bogged down with these formulas. Remember, it's just how far from the x-axis is it. So you're going to always draw them out, and then you're going to figure it out. So let's take a look at a couple examples. So if I draw a 120 degree angle, so here's my x-axis, my angle's here to 120 is about there. So there's 120 degrees. My reference angle is how far is it from the nearest x-axis. So how many more degrees would I have to go to get to this line? That's what I'm trying to figure out. So this graph lies in quadrant 2. So I need to go 60 more degrees to get to my reference angle. So my reference angle is 180 minus 120. So it is 60 degrees. So if I graph 53 degrees, so 53 would be here to somewhere around here. So its closest x-axis is this one. That means they are identical, so my theta prime is 53 degrees. And that was in quadrant 1. 948, what I'm going to do is I'm going to subtract 360 until I get a positive number between 0 and 360. So I'm going to keep doing that, and it gets me 228. So that's really what I'm going to graph. is a 228 degree angle. So here's about where it would be. So my theta is how far away from this line is it? So that means I need to take 228 and subtract 180 because that's my closest x-axis. And I get 48 degrees. So same thing we're going to do when we have a negative degree. I'm going to add 360 until I get a positive number from 0 to 360. And this was in quadrant 3. So if I keep adding 360 until I get a positive number, I get 315 degrees. So that's here. Because the direction I'm drawing these does not matter because my reference angle will be exactly the same whether it's a positive or a negative angle. 315 degrees is about right here. So my reference angle is this value right here. So theta prime equals 360 minus 315, which is 45 degrees. Okay, if you have questions, please let me know.